Alright, so video questions. Hello. For chlorine, it just has 17 protons, because, right there. And, 37 minus 17 is 20. It's negative charge. -1 is the net charge. For magnesium, it's giving us the protons, which is 12. 12 right there. The number of neutrons. Add those together, you get 25. And there's 1 electron and 12 protons, which means there's a net positive charge of only 1, which confuses me because magnesium is usually 2 plus. I'm assuming these two are supposed to be switched, but I could just be wrong in general as well. So there's that. 36 electrons were given, and a net charge of 3 minus was given, meaning there'd only be 33 protons. 33 is arsenic. So 30 plus 43 is 76. For the AMU, and -3 charge. 50, 39. 39 is the number of electrons, and there's no net charge, so it's the same as the number of protons. And 39 is uridium, something. Yttrium, however you say that. And, number of protons, 39. 39 plus 50, 89, there's that. This is just given. Calcium is 20 protons. So 20 protons, 20 neutrons, and plus 2 charge, meaning 18 electrons. So there's that. Which subatomic particle determines the chemical behavior of an atom? Well, I think it's multiple, but mainly protons, because the number of protons an atom has determines, the weight of the atom, the reactability, what reacts with it, what doesn't react with it, the state of it. The protons, they control a lot, I guess, when it comes to an atom. Like, one number off could be like something completely different. But on the other hand, like electrons as well, like the amount of electrons an atom has, like it could be very very wanting to take like an electron, like something like fluorine, or something like oxygen or sulfur, like with the amount of electrons it has on its outer valence shell. And then something like hydrogen only has 1 electron, like on its outer valence, and would like to get rid of it, so like would give it away. So there's that. Neon has 2 naturally occurring isotopes, neon 20 and neon 22. Which one's more abundant? So to determine this, I looked at neon's average AMU, and it is 20.180. So I can just infer, it's a lot closer to 20, and it is 22. And so I can just infer that the abundance of neon 20 is just a lot larger than neon 22, because it's a lot closer to 20 than 22. This one's just the binary compounds, copper oxide, Oxide has a 2 negative charge, and shows here that copper is a 2 plus. So they just, this is the molecular or empirical formula, I believe. That, this is just how it should be written. Ammonium nitride. Nitride is N3 negative, and ammonium has a +1 charge on it. So this is ammonium, 3 ammoniums to balance out the charges there. Phosphorus trichloride, but there's tri. No, it's just, covalent, I believe. Or scratch that, whatever. I just know that I have to write out, like, literally what it says. Like, it's just phosphorus, nothing before it, so it's 1, and trichloride, which is 3 chloride. So, yeah, it's just PCl3, which is nice. Nitric acid. I know nitrate is NO3, and there's like a rule where it's like ic, the number of if it's ic, like it doesn't change the nitrate, and like for it to be an acid, you need a hydrogen, like right here. So HNO3. If it's OUS, like OS, I think it's 4, and like hypo, like there's like a hypoic, I believe it's like 2, or at least 1 less, something like that. I just know that with this ic here, it just stays how it naturally is. So there's that, HNO3. Magnesium hydroxide. Magnesium has a 2 plus charge, 1 minus charge. So you need 2 hydroxides to balance out the charges with magnesium, which is great. And naming these, this is, that's not a question. This is sodium carbonate. CO3 is just carbonate. Carbonate has a 2, has a 2 minus charge, and sodium has a 1. Yeah, sodium has a 1 plus charge, and so you need 2 sodiums to balance out the charges for carbonate, which is CO3, sodium carbonate. FeS, so iron sulfide. You can tell it's 3 because sulfide has a 3 negative charge, and it's just FeS. Like there's no, if it was iron 2, it would be like Fe3S2 if it was iron 2, but it's not like that. It's just all the way through, meaning iron has a 3 charge. It's already balanced out. So that's cool. This is hydrogen sulfate. It's just the hydrogen here and then the sulfate right there. Hydrogen sulfate. Nice. And then this is pretty much exactly what I was saying. With this, like phosphide is a 3 negative charge, and there's 3 irons and there's 2 phosphides. So 2 of that is 6 negative, and 3 irons, it has to be 2 positive charge to add to 6 to balance out the charges. There you go, bada boom. And this is just chlorine oxide. This is either chlorine oxide or chloride oxide. But either way, chloride, it's chloride. Chloride has a charge of 1 negative, and oxide has a charge of 2 negative, and that is that.